Good afternoon. We'll go ahead and get started here. For those of you that haven't, that I didn't get a chance to meet, my name is Rex Engelking. I work for PCCW Global. I'm the ICT chairman for AmCham, and one of my vice co-chairmen right here, Benny Lee, CenturyLink, is also with us today. So we're glad to have you here. The topic is cloud, so hopefully that's what you signed up for. If it was something else, well, stay anyway. You've had some food, relax, that kind of thing. Make sure you've gotten some food. I think there's still a bit left over, so if you want to hurry up and grab something now, grab it. We're pretty informal here. A couple of housekeeping items. Just mobile phones, if you can switch them to silent. In fact, it's a good cue for me as well. I'm usually the culprit that doesn't do it. Do that, and then also if you're doing any note-taking or anything, if your keys, if you can turn off the ticking of the keys, that helps as well, just for everybody's sanity. So a couple of other notes. You've probably, as you've had a bit of time networking, you might have noticed that people have different colored name cards, or I see, in fact, a lot of people have their own name cards in there with a designated color. And the colors actually are not random. They do mean something. And if it's red, which we don't have any today, that's our Board of Governors. The yellow, as Benny and I have, means we're part of the leadership of the committees. And then blue name tags designate you as a member of AmCham. So that's great. But our favorite color is either non-color or the grays. Why is that our favorite? Because you're not yet members of AmCham. This is a great opportunity for you to sign up right after this event. The gentlemen and ladies in the back can help you do that. It's so easy to do. You just you write a check. They'll even take cash. I think they'll take a credit card. They're pretty easy. So at the end of the day, have a think about that. We have a lot of for our members. Some of the additional benefits are the fact that we're video recording this, for example. This will be archived. You can access it later if you wanted to look through those notes. So there are things, benefits like that the non-members don't have. We are grateful that the non-members come. We want you to see what we do here at the Chamber. We're a very active Chamber. Most of the activities are driven from the committee level. We do over 300 activities a year, so very busy. We do look after a number of segments, and of course this one is the ICT. It's not a segment per se, but it's a bit more generalized, and we try to cover topics that are useful to our members and our non-members. So with that, we'll go ahead and get started, and we'll let Zane come up here and talk to us. Now Zane is from Amazon Cloud Services, so hopefully you'll know, you've heard of Amazon. If any of you haven't heard of Amazon, don't admit it to us now. You can tell us later. It's okay. Yeah, Zane's been here in Hong Kong 4 years, 5 years? 9 years. 9 years. Time flies. Time flies. Next thing you know, you'll be here for 20, and you'll be like some of the other folks around here. He's been with AWS for a couple of years. Before that, he had his own large data, big data analytics firm here. And prior to that, he worked at companies like BlackBerry and has been in the industry for 15 years. I've heard him speak before. The good thing is he's very engaging, so I think you'll enjoy his topic today. And he's promised that he's kept it at a level that all of us will probably appreciate. I'm not very technical, and it's always good to see a lot of pictures. He's promised a lot of pictures. So we should be good in that frame. One of the things, normally in this setting, we want to be as interactive as possible. And so if you have a question, feel free to raise your hand and ask your question. Instead of passing around the mic, because we are video recording this, we want to record the question as well. Zane has said that he would repeat the question for everybody, just to make sure that we get it recorded. But please feel free as we're going through this. If you do have questions, he's definitely open to answering those, so we don't have to wait till the end. We'll go until about 1:30, and then we'll wrap things up so you all can get back to your day jobs. And hopefully this will be a time well spent at the Chamber. So with that, Zane, I will turn it over to you and let you tell us a bit about cloud.
Thanks, Rex, and thanks for giving me the chance to speak to you guys today at the American Chamber of Commerce. My name is Zane. I'm from Amazon Web Services, a subsidiary of Amazon.com. And actually, I've been asked to talk to you a little bit about cloud computing in general. So essentially what it means, how this is changing, how companies operate, how this is impacting innovation, and also how this might actually impact business models moving forward as well, too. So as mentioned, I come from a company called Amazon. So if you're one of those that actually don't know what we do, we're kind of a funny company. We are actually an e-commerce company, but we also have a couple other major divisions. So beyond the e-commerce company, we have a division that does seller services. So for folks that want to use our platform for e-commerce and distribution and fulfillment, we actually handle the logistics on the back end as well too. There's a third part of our business though, which is called Amazon Web Services, and that's where I'm from. And this is what's called an IT infrastructure business, which sounds really unsexy and really boring, and it might be, but not for me. So what Amazon Web Services does is something called cloud computing. And what cloud computing is, if we look at more of a traditional definition, is this concept of on-demand delivery of IT resources via the internet, which is a technical concept, with pay-as-you-go pricing, which is a business concept. Okay, so what does this all mean, though? So when we talk about on-demand, what does on-demand mean? Does it mean something like a FedEx delivery truck? So 2 days later, someone brings some package to you and drops it off at your front door? So that's what Amazon does. But it's not what Amazon Web Services does. Is it something similar to like ordering pizza, where the pizza comes in 30 minutes? Not in Hong Kong, though, is it? I think Pizza Hut's normally like 45 or 50 minutes here. But similar concept where you order something and it reaches your home. Our concept of cloud computing is actually more like electricity. So this is a really interesting thing around delivery. So when you deliver what we call IT services to you, you request them on demand, and they're available to you almost instantaneously. So when you think about IT infrastructure, IT services, computers, servers, et cetera, historically you think about going to maybe a website or calling your technology partner, issuing a PO, having that PO accepted, then saying, okay, it's going to take 2 weeks for that piece of hardware to get shipped to your company. And then from there, if someone looks at it, they maybe need to do some installation work on it, harden the OS, harden the hardware, et cetera, and this whole process normally takes weeks or even months. In the world of cloud computing, we're talking about everything being on demand, like electricity. Now, the interesting thing about electricity, though, is it doesn't seem like it's an IT resource, does it? It doesn't seem like a physical box or physical piece of hardware, physical storage, but it can be done in this way via something called virtualization. So if you think about it this way, your computers don't need to be in the closet of your office or in a data center. They can be hosted by someone else, in this case, someone like Amazon Web Services. And if Amazon Web Services hosts these and makes these available to you on demand, where you don't have to think about buying all this hardware, managing it all, et cetera, then you can use this to your advantage. The crazy thing about this whole business model is the economics of how it works, though. So we're in this world that's called pay-as-you-go. And pay-as-you-go means the moment that you start using the service, you pay for it. The moment that you turn it off, you stop paying for it. It's like renting a bicycle, right? So when you ride the bicycle, you put in, like you're in Taiwan or something, you put in your smart card, you ride at the next destination, you click it back in, and the fees are removed based on your usage of that actual bicycle. So in this world, what we're now saying is not only can you have things like compute power, servers, in real time immediately, but you only pay for it when you use it. So if you use it for 1 hour, you pay for 1 hour. Use it for 1 week, you pay for 1 week. In the extreme case, use it for 1 millisecond on Amazon, you pay for 1 millisecond worth of compute. So the dynamics of this from an economics and technology perspective, I think are pretty interesting. And the technology that is underlying this leads to some really interesting consequences too. And the first of which is essentially infrastructure in a true cloud computing environment is virtually unlimited. So what I mean by that is, the scale at which a company like Amazon operates its IT infrastructure essentially means even if you really wanted to, you probably could not exhaust all the capacity that we have available to us. This is a bit technical here, but if you wanted 100,000 cores to run an HPC workload and you needed it for 3 hours, you could get 100,000 cores for 3 hours within 10 minutes. So 100,000 cores would be something similar to say, maybe, divided by 8, so I don't know, a couple thousand of servers. So you could actually say, I need a couple thousand of servers. I need those for 3 hours to run this process. Once I'm finished using with it, I discard it and only pay for those 3 hours. So cloud computing is all about this idea of immediate consumption of IT resources and paying only for what you use. This is pretty crazy, this concept. And this is why this industry is actually changing the way people innovate and how people build and service new products. The other thing that becomes interesting is, remember we said that you just use a service and you discard it. Well, if you do that, you can do something really funny with how you use computing. You can actually make it what's called elastic. So elastic is a pretty interesting concept. Elasticity is about this whole idea that as you need more compute capacity, you increase it this way, or you increase it this way. Either you have more servers, or you increase the memory or increase the performance of that actual server. And when you don't need it anymore, you turn it off, or you take it down. So in this world, you can actually build some really interesting applications that cost not really a lot of money to run. And I'll talk about the consequence of that a bit later on. Yes?
Maybe you will speak about that, but how is it limitless? I mean, the server
Yes.
and whatever else, the infrastructure in the background, is, at the end of the day, it's physical.
Yes.
Right? There must be a limit also on the chips and whatever else, maybe many chips, but there must be some limit somewhere.
For sure, for sure. So the question was, I talked about it being limitless, and it'd be a bit more of a marketing, salesy sort of pitch there. It's more like in terms of the practical usage that you would have. You would probably not be able to exhaust all the available capacity that's available for any application that you had. If you wanted to, you could try. I'll give you an example a bit later on about something that people have tried in terms of trying to build a supercomputer on our platform. Top 25 supercomputer, and 100,000 plus cores running an application, and cost $30,000 for 18 hours, and that was nowhere close to exhausting capacity. So in a true cloud computing world, where your provider essentially has built up infrastructure, it's not likely that you will ever be constrained by the compute requirements that you have, because there aren't suitable applications that would actually require you to exhaust all that's available.
Why then do you have so much capacity for what purpose?
This is what we
You
do.
overbuilt, in other words.
Not necessarily, not necessarily. But what we try to understand are how people actually use the services. So that might require us to look and understand how do the peaks and troughs of usage work, and what are those actual requirements. There's different ways to look at virtualization, different ways to be able to look at how to deal with different workloads as well. So it's about planning and scheduling, but there is capacity within our environment. In other words, yes. Question in the back.
Isn't there a stat that Amazon are now adding on a daily basis what they used to run on like 10 years ago as a company?
Yeah, so the question is, isn't there a stat that, and this is a good Amazon pitch, thank you very much.
Partner, right?
Yeah. Yes. So there is. So Amazon Web Services actually adds enough capacity in our infrastructure to be able to handle the $7 billion business that we were about 10 years ago. So if you think about the number of servers and infrastructure and racks that we're putting into our infrastructure globally to handle that $7 billion business 10 years ago, that's probably not a small amount of infrastructure. And we do that on a daily basis. So there is some level of ensuring there's adequate capacity there. And that build, you can call it overbuilt, or you can call it proper resource planning, which might be a nicer way to talk about it. So this elasticity is pretty cool though, right? Because now what we're saying here is now, okay, when you start with something, you start with just one server. And when you need 5 servers or 10 servers, 100,000 servers, you just request it. And when you don't need it anymore, you throw it away. It's kind of disposable in its nature. So this creates something really funny. So when you talk about elasticity, this pseudo-infinite capacity, when you start building some sort of technology and business rules around this concept, then you create something which is pretty funny, actually, which I think we call auto-scaling sort of in our world, but it's more like this idea of automatically elastic. Automatically elastic is kind of like saying, let's build some intelligence to how we use our compute power. So in the more traditional world, Your IT team might say, okay, this server is not performing very well. My end user customers are complaining. My internal staff are complaining because it's not working fast enough or something along those lines. In the world of cloud computing, if you're actually monitoring core metrics and this core metric is exceeded, you can actually trigger a request to add capacity. So this might be something simple like time of day. So newspapers here in Hong Kong, for example, their mobile applications, they have the highest traffic. Guess when? When people are riding the MTR in the morning. So that's going to be between about 7 a.m. and about 10 a.m. So in that scenario, you might actually increase, based on time, the amount of servers you have available to make sure your customers have the best experience. And after 10 o'clock, bring down that actual infrastructure. That's using business intelligence. What if I said, okay, well, what if I have a queue of people ordering tickets on my website? Or what if I have a queue of reports that have to actually be completed? In that scenario, you can use that as a trigger to also expand the number of servers available to actually process that compute. So in this case, auto-scaling could be triggered by some sort of action, like this ice cream appearing here for this sheet. And in this case, when that activity happens, then you have a lot more capacity available to you. But it goes both ways. It's not just scaling up. So in the scenario where you actually need to tether back down, you can monitor those same metrics. So if the queue of people or queue of requests is now, maybe you increase the amount of compute capacity you had before because you had 100 people or 1,000 people queuing to complete some sort of task. But now that queue is down to 5. Now you don't need hundreds of servers to address that issue. Now maybe you just need 1. Or in the extreme case, maybe you don't need any anymore. That's the whole concept of automatically being elastic. So you can actually build intelligence around how you use computers and servers now to be able to address this burst actual requirement. So when we look at the technology and when we look at this idea of this elastic concept, there's some interesting business consequences from this. Okay? So the first one, of course, is you probably can save a lot of money. Probably. There are some what we call anti-patterns where it might not make sense to move things to the cloud. But in almost every example, there are ways that you're likely going to save money by moving something to the cloud. And the reason is because you actually are doing something which is hugely and massively efficient. But from a pure CapEx perspective or pure financing perspective, you don't have to think about refreshing servers. So today you might have a life cycle here with the servers or equipment that you own. It's maybe 3 or 5 years or something. Every 3 or 5 years, you got to buy a whole bunch of new servers, a bunch of new equipment. That costs a lot of cash, as a cash flow impact to your business. This is sometimes called capital expenditures, CapEx. Well, if you are in a model where essentially, like in the cloud computing world, where whenever we release new hardware or our other people in the industry release new hardware, you can use that latest hardware. You can migrate your workloads easily across, and you're always using the latest, best performing, best value, what we call compute. So in this case, you don't have to wait for 3-year horizons. You can change whenever you want, whenever the value makes sense for you. And you don't have to worry about this massive capital outlay every couple of years when you actually do that refresh. In Hong Kong, in a similar vein, we have lots of these things, which are data centers. These are colo facilities, IDCs. You're also paying for rent for these. You might be paying for power, for cooling, for other components to it. And these are actually massive costs that you have to think about when you actually run IT infrastructure in places like Hong Kong. And in this model, in the cloud computing model, you don't have to worry about that either. And eventually, what you hope you have when you move applications across into the cloud are, happy customers. And hopefully, a lot of them. Hopefully, a lot of them. And irrespective of how many you have, your hope is that you're always going to be available. And in the case of the cloud computing world, you can actually architect your applications to essentially be guaranteed to be available. And that's something that's historically a bit more difficult to do, or very expensive to do. But in the world of cloud computing, because it's disposable, because it's real time, because it's dynamic, you actually have the ability to be able to ensure that when you have 1 million concurrent people trying to access your application or trying to access your service or trying to do something with you, you have the capacity to handle that. In the old world, you may have actually planned and said, okay, I think in a hypothetical world, I have a 20% chance that I'll have 500 customers queuing up. In that world, you would build to that 500-person capacity. What happened if you had 501 customers or 600 customers, 1,000 customers? Those other customers wouldn't actually get access to your service, or they'd have a really poor customer experience. And the world of cloud computing allows you to address that. Okay, so that's a high-level concept of cloud computing. Not just an Amazon concept, but a general cloud computing concept. I want to talk a bit about marketing jargon now as well too. So, I just completed the presentation last night, so hopefully it's okay so far. While I was doing it, my daughter was asking, why are you looking for pictures of donkeys? And I also didn't realize that donkeys they're actually pretty cute actually. But in the world of cloud computing, you hear this term something as a service all the time, right? This AAS part. And as a service is effectively what we're talking about, right? Almost anything you can think about in the IT world can be provided to you as a service. So when we talk about as a service, it's not something like a piece of hardware going to you. It's a subscription to some sort of service to use something. And in the world of cloud computing, there's three general terms that you might see: IaaS, PaaS, and SaaS. Sometimes they're called IaaS, PaaS, and SaaS. People haven't figured out how to pronounce IaaS as a word yet, so they just list out the terms. And what these are somewhat related concepts. So at the base of cloud computing is something called infrastructure as a service. Now this might be something that a company owns themselves already. So a company like Salesforce.com, who some of you may use for CRM, they're known as a cloud computing company. And they have an underlying infrastructure which helps them manage and scale for whatever demand they have within the customer base. Then you have other companies that offer something called platform as a service, which are essentially tools that allow people to run infrastructure as a service activities without having to learn about what infrastructure as a service means. By the way, Amazon plays in this space. Folks like Microsoft and Google, they play in this space. And IBM Software, CenturyLink, they play in this space here. What most people are most familiar with around cloud computing is something called software as a service. So if you're an iPhone user and you use something like iCloud, if you're a Dropbox user, if you're a Netflix user, these are examples of what are called software as a service. And sometimes the word software doesn't quite make sense anymore, but the whole idea here is you have an infrastructure that can handle whatever workload you have, whatever number of files or storage that's required, and in the back end, someone's taking care of that. And that's someone probably that's sitting at this layer. But they've packaged it so it looks really nice. So you download an app for your laptop, you download an app for your phone, and it just works. But underlying that is actually a cloud computing infrastructure. Okay, so that's what this star as a service sort of means. So there's another term here, which, and this is a bit more of an Amazon view though. Okay, so those in the industry may have differing views on this. There's another term called private cloud. And from an Amazon perspective, private cloud is no different than how you host servers internally today yourself. It's usually at a colo-location, it's usually with limited capacity, and doesn't have that scale to be able to do things in broad scale. So whilst a lot of people say, hey, you can enjoy the benefits of cloud computing by hosting your own infrastructure, remember we talked about this concept of practical, limitless capabilities of cloud. In a scenario where someone says, hey, you can build your own cloud, that's pretty difficult to achieve. One, it'll cost you lots of money to do. You got to pay it up front. Two, you might actually have a restriction in terms of the amount of storage or service available to you. And number three, it doesn't have the benefits that you have around being global, having access to services and infrastructure that's used by millions and millions and millions of people. So I would just caution when people talk about private cloud to have a think about whether they're talking to you about what is really cloud computing versus something which is just essentially application hosting, just sort of packaged in a different way. So the main thing, though, around cloud computing, though, in general, especially at the infrastructure as a service level, is, though, and this is a list of some of our customers, by the way. We've got over 1 million customers using Amazon Web Services in over 190 countries around the world. But there's a common theme, especially with these folks here. None of these guys are IT companies. So the common theme around cloud computing and the thought process around businesses using cloud computing, whether it's us or SaaS products or PaaS products, is they don't want to be in the business of managing IT infrastructure. That's not what they're here for. Right? Ticketmasters, they sell tickets in the US for large events. NASDAQ operates a stock exchange. Sharp, they manufacture consumer electronics. So companies, when they think about the cloud today, are thinking about, okay, well, are there certain things that I do that I don't need to actually be doing? In a world of cloud computing, we can take that away from you. So this is a little bit technical. This is the most technical we're going to get today. But in the world of cloud computing today, and companies, they're starting to go and say, okay, well, instead of me thinking about building and managing my own IT infrastructure now, why don't I find a partner that does it better than me, does it at lower cost than me, and hopefully does it with a cloud-based model? And in this scenario, what you see now are companies actually expanding and extending their footprints for IT. So it's not just within their own data centers anymore, within their own companies, but instead they might put in place something like dedicated connectivity to a third party. This might be Amazon, might be one of our competitors, might be other people. But the idea here is you can leverage the power of compute in conjunction with what you already do on premise. And this model becomes pretty compelling because at the end of the day, you now can access the benefits of whatever cloud computing provides to you while still maintaining whatever control or requirements you have in controlling data within your own environment. But the main thing is, by outsourcing these components, the company focuses on what they do best themselves. And that's a really important part of cloud computing. This is the example I was talking about before. So if you wanted to build a server farm with 156,000 cores, it would probably cost you circa 30-40 million US dollars, and it would take you a long time to do it. But if you're a research company, say you're doing genomic sequencing, or you're doing some sort of credit risk analysis or financial modeling, and you need access to a whole bunch of computers in a very short period of time, and you don't have that money up front to build out your own infrastructure, cloud computing allows you to be able to do something like that. It allows you to do some really interesting things. In this case, build a supercomputer that essentially is a top 25 supercomputer in the world, using essentially commercial services offered by Amazon. So the main thing here, though, as mentioned, is we're trying to remove what we call undifferentiated heavy lifting. So you're in the business of innovating for your customers. You're not in the business of operating a data center. You're not in the business of managing databases. You're not in the business of buying hardware and then asset tagging it and then discarding it when that life cycle ends. You're in the business of creating solutions for your actual customers. So you should focus on them. And so I think the biggest way cloud computing is impacting business in general is by removing barriers for entry, which is a good and bad thing for us in this room, right? By removing barriers to entry, it means that your space might become more competitive because another new company that's starting up might not have that same burden of traditional IT infrastructure that you have today. But on the other side, it allows you to be able to focus on acting like a startup yourselves. So in the case of Amazon, companies like Dropbox and Airbnb and Spotify and Instagram, they started on us when they were very small. So Amazon is a funny company. We're not very high profile. Some of you might not even know that we had an office here in Hong Kong. But we are focused on one really important thing, and that's being what's called customer obsessed. So we treat a company like Airbnb when it was 3 people no differently than the US government. Okay? So what I mean by that is when someone comes to us and says, hey, we have a problem we need to solve, we'll say, okay, let's help you solve it. Because we never know who's going to be the next Dropbox or Instagram or Airbnb or Pinterest or Netflix, who are some of our what we call startup companies. And in this scenario, what these startups do is they use us to be able to help them with scaling and help them with cost management, help them with matching revenues to expenses so they don't have to overinvest up front. And for these startups, what it means for them is they can focus on what they're really meant to do, which is not IT infrastructure. It's actually giving the customer the best possible experience. They're building good products, building good services. And the interesting thing is this impacts the more traditional world. So this is a hotel chain called Kempinski. They're a European-based sort of luxury type brand. They've got hotels here in Asia as well. So in this case, this is more of a traditional sort of company. In their world, they've also gone and said, okay, I don't want to operate my own data centers anymore. They've gone and said, put everything into Amazon in this case. And let me focus on the customer experience. Let me focus on the offline experience when I greet someone that comes into my hotel. Let me focus on loyalty. Let me focus on increasing sort of per visit spend. So instead of wasting cycles and resources on something which doesn't differentiate their business, they instead reinvest those funds that were originally allocated for that on something which does matter, which is, in this case, customer service, or improving the way their hotels operate. And the reason why startups can do this, and the reason why business can do this is because if you think about this whole idea of elastic compute and this idea that things are disposable, what we call the cost of failure decreases. So what does that mean? What does the cost of failure mean? Cost of failure essentially means you can experiment with something very quickly at low cost, and if it doesn't work, you throw it away. And that experiment was something that you ran on a cloud provider for maybe a week, or an hour, or a couple days, or a couple months, or whatever it is, and you don't have that upfront cost that you had in the previous business model that actually goes to waste now. So our view, and I think what cloud computing can actually do is it actually unleashes the power of creativity. The reason why startups are where we see so much innovation around the world today is because they can. So someone straight out of uni or straight out of high school can go and say, hey, let me set up Amazon accounts and let me start to play around and build my own mobile application. Let me build my own web application, build my own company. And instead of having to, in the past, raise X hundreds of thousands of dollars just to get companies set up, get infrastructure set up and start going, today, just with a personal credit card, you can run your own small business for a couple dollars a month. You know, for me, with my own startup here in Hong Kong, I raised $300,000 US for it, not massive, but I didn't have to have a database administrator. I didn't have to have a colo provider for my infrastructure. I didn't have to buy actual hardware equipment. I ran it all on AWS in this case. So it allows individuals who have this concept of what they want to do and pursue as a dream to be able to do so with essentially limited risk. So by doing so, you can build applications and services that are very much customer-centric, that allow you to continuously experiment, allow you to measure relentlessly to make sure that experiment actually has some tangible change, and allows you to build eventually good customer-centric products. And that's the end game for all of this. It's how do you make your customer happier, more satisfied, because that's what actually drives profits and loyalty and customer lifetime value. And if you don't focus on those things, then you start to lose market share, you start to lose employees, you start to lose your edge. But in the world of cloud computing, this sounds really philosophical right now, but by taking away some of these resources that are allocated to things that don't make any difference, you can actually focus on the customer. So a startup, essentially, we think is defined as a human institution that's designed and defined to define new products, right? That startup has one product that they think is going to work. People are putting their dreams on it, they're putting their own money into it, and they hope that it's going to work. It may or may not work. You don't know. Historically, enterprises were the same. Are they the same today? I'm not sure. In some respects, they are. You might have, different product managers that are building new products and services, but the pace at which that you launch these services might be not as fast as it was before. There's no reason why you can't leverage platforms like those in cloud computing to be able to achieve those same new innovations. Okay, so a bit of a segue here. So do you know how startups think today? So if you're operating your own startup and you're 2 or 3 guys or gals from, say, Hong Kong UST here, what are they thinking these days when they want to build something? Some of you guys probably know this stuff, but just a random sort of question. So a lot of them are following something called lean startup methodology. Any interest in walking through what this is in sort of 1 or 2 minutes, or everyone's familiar with this? No? Okay, so lean startup methodology is a concept that is a marketing term now, but originally was based on the idea of the lean manufacturing process by Toyota in Japan during the 1970s and 80s. And the concept of this has now been applied to startups, technology startups in particular. This is not just software, but can extend to hardware, and any other company in general. But basically the concept surrounds this idea of not wasting time to build something that you think people want, but only focusing on building things that people actually want and things that help improve the way that your actual product performs. Very weird concept. So let me take you step by step through how someone that's starting up a business might actually run their business today. So first thing they might actually do is say, okay, I have some problem. Let's make something up. I'm really gonna make something up, so this might not work. But let's say I'm a big pizza lover, and here in Hong Kong, I sometimes want to order pizza from Pizza Hut, from I don't know, what are the other pizza brands here? Pizza Box, Paisano's, Pizza Express, right? And then, but I also know that it takes too long for these guys to deliver normally. So now I say, okay, I think there's a problem here. Lots of people in Hong Kong have the same problem where I don't know if I can get a spot at that pizza place, or I can order that pizza in time. So someone says, okay, well, why don't I test and see if there's demand for a pizza ordering application in Hong Kong? Okay, so what someone might do is actually say, okay, well, I don't want to spend any money and write an application yet. I might just go buy an ad on Google AdWords or on Yahoo Text Words and say, okay, pizza ordering Hong Kong, buy those meta words. And you might actually just put in just some landing page which says, hey, sign up to download the latest Hong Kong pizza ordering app when it's available. Okay? So this experiment costs maybe $20 to run for 1 month. They might find randomly that maybe 600 people have gone and clicked on this ad and gone to this landing page. That suggests that there's some demand for what you're actually pitching. Then they might go and say, okay, well, if I'm going to do that, then why don't I then build a very simple application? This application might just be something as simple as, here are the names of these pizza joints, here's the phone number, here's a menu. And then see how many people actually download that app or go to that website. Then when they do that, they can start testing that application. So what if they said, okay, what if I order these things differently? So what if I put Pizza Hut first and then Pizza Express second and in different orders? Would that actually cause a reaction for the customer that creates some sort of subsequent reaction? So in this case, if you had an affiliate program, so maybe you work with Jargon Restaurants Group now, and now every time you refer a customer that dials through your app to Pizza Hut gives you a 0.5% commission or something like that. Okay, so you might actually find out, okay, I want to optimize my application so that more people click on the Pizza Hut button to trigger that call to order pizza. You might experiment with, okay, if I make the order differently, if I change it from alphabetical into Pizza Hut first, will that increase the what's called conversion? If I change the button to orange color versus green color, will that actually increase conversion? And you start running these experiments, and eventually, the more and more you run, the more and more you learn about your customers, and you change these on the fly. So as you improve that experience, the customer has a better and better experience all the time. In the world of cloud computing and startups, by actually building a model like this where you rapidly iterate, you take advantage of the disposable infrastructure, essentially, you eventually build a product that customers really like. Why? Because you're always collecting that feedback. You understand what they actually would like to see fixed in that application. So eventually, you start off with a basic idea, but eventually you have something that has what's called traction because you've built something that customers actually can use and are giving you feedback to actually use. And big companies do this too. Well, this is what Amazon does. So if you actually, just randomly, if you want at home today, or at work today later, if you have multiple browsers on your desktop, just open one using, say, Chrome and Mozilla or IE, and go to the Amazon website. Guess what? You're probably going to see 2 slightly different views. Why is that? We're running experiments on you. Don't worry, it's not too bad here, though. So in this case, this is the difference between a Mozilla browser, so a Firefox browser, and Chrome browser. It's taken at the exact same time. So what's different? Well, we've changed the banner here, right? The title. The difference here, you also see another sign-in button here on the side. Why would we do that? Well, we don't know, right? We're testing it to see. If I do that, does this increase the propensity someone's going to purchase something? Does this increase the propensity someone's actually going to sign in, which makes the purchasing experience easier? So if you keep running these experiments frequently, you start to gain some insight in terms of what allows the customer to complete that purchase or complete that engagement with you in a much more effective and quicker way. So The goal is to remove friction, and use WD-40 as an example here. So on our e-commerce site, it's sort of the same thing. So you keep experimenting with different things. You might say, this is a really weird interface because lots of buttons and things that are kind of random, but they're not because we test them. So in this case, if you go to a WD-40 product here, you might actually see that we're trying to simplify the entire purchasing experience. We've seen this because we've done it through experimentation. So instead of asking someone to go and, this is an 11-ounce WD-40 product. In a traditional world, maybe you need to go to another web page to find the 12-ounce version or 8-ounce version. Simplify that. Simplify ordering in bulk. This person has priced theirs at $11.75. Well, guess what? Someone else is selling the same thing for $6.44. But the idea is here, you remove friction to ensure that the actual performance of that customer is faster. And you only achieve this by experimenting, by seeing what works. And this infrastructure that supports this allows that to actually happen. So how frequently can you do these experiments? So at Amazon, we run 95 experiments per minute. Okay? So 95 experiments per minute is what I actually run at Amazon. And there's methodologies around how you test to make sure that these things are statistically significant. But when you do these experiments frequently enough, you start to build a model which allows you to predict how consumers will behave. And this allows you to optimize performance of things like your applications or performance of anything else that you do. And this whole concept applies not just in the digital world, but applies in the real world as well too. So if you have a retail facility and you're looking at things like traffic flows for how people go through your store, you're looking at end caps on point of sale materials, you're looking at anything else, it's the same experiment where you can actually track the effectiveness of these experiments, but you want to do so really rapidly. Okay. So the great thing is when you do these experiments, and if cloud computing is underlying infrastructure for you, there's very much a good chance that when you discover the secret sauce and you start to grow rapidly, you can support it. Or if it completely fails, you start again. And the risk and cost was essentially very limited. Okay. A couple more slides left, almost done. So hopefully it hasn't been too boring for everybody. But a final note on emerging business models for this world. So what's really interesting for me, in my role at Amazon today is I don't just work with people that consume our services as customers, like enterprises, but I also work with companies on developing joint business models and go-to-market models with them. And what's pretty interesting is the donkey comes back. Because the emerging business model, I think, is pretty interesting. So I think everyone here has heard of Adobe before, the company Adobe. Equally, hopefully everyone's heard of something called like Photoshop. Okay? So up to about 2 years ago, when you bought Photoshop, you bought Adobe Creative Suite, you had to pay for it as a box software. You would have gone to Office Depot or something, or gone to one of the computer centers here. You would have paid something like $400, $500 for a package of software. What did Adobe do a couple years back? They changed consumption of their software. Now you pay on a monthly basis, either for the entire suite or for individual applications. And this is sort of what we call SaaS 1.0, where you subscribe to software on a monthly basis. What we're seeing within the startup world is a variation of this, which is kind of like Web 2.0, so kind of SaaS 2.0. And in this world, so in that previous model, this is kind of like licensing still, right? This is almost just a pure licensing model. We don't care how frequently you use it, don't care how much you use it. You just access the license and you can use it how much or how infrequently you want to use it. In this Web 2.0 world, you see a lot of pricing like this. This is something called Shopify. My wife has an online e-commerce business here, making children's clothes. Her store is actually hosted on Shopify. And in the world of something like Shopify, they say, okay, we'll host your e-commerce platform for you, including merchant banking and all these features, and we'll charge you different fees based on different functions. Part of it is related to things like storage, 1 gig storage, 5 gig storage, and limited storage. How can they do this? Well, they know what their costs are because they're running it under an underlying cloud infrastructure provider. Or they then remove certain features and increase them based on the actual package that you subscribe to. This is kind of a Web 2.0 model where you discriminate from a pricing perspective based on features and functionality. Now, what Amazon believes, and we actually have something that's an app store for Amazon Web Services, there's about over 2,000 applications that are available there today, is you can consume, we believe, software moving forward in a bit of an even funnier way. So in the same way that you consume infrastructure on an hourly or per millisecond basis in Amazon today, you can also consume software on a per hourly basis. This becomes pretty crazy, right? So in that first model, we talked about Adobe saying, okay, sign up for a month, use as much as you want. We see this trend because we're at the head of the curve here where software vendors are offering their same software for a per hourly basis too. And this makes sense because if you are running an application, your application, and it requires you to scale to thousands of compute instances for 3 hours, in the historic world, for their software to work, you'd have to call up a distributor, put in a PO, wait for someone to ship you the actual box or someone to send you an actual key, and then you wouldn't be able to address that real-time scaling. But in the world of cloud computing, to handle that real-time scaling, you need software to be able to scale at the same time as well. And so what we see is an emerging change where software is consumed on an hourly basis as well. And this is pretty good for consumers, pretty good for enterprises as well, because the cost base for doing so typically will probably be lower because you don't have to have any excess spend here. All right, so last 2 minutes. Bit of a pitch on AWS, if it's okay. So remember, I came from a company called Amazon Web Services. Sorry for the marketing and pseudo-hard sell here. Launched in 2007, multi-billion-dollar business, over 1 million customers in over 190 countries around the world. These customers are anywhere from startups and not-for-profits all the way through to large enterprise and governments. And we're a funny company. So essentially anything that you can do on-premise within your own server environment, we think you can do on the cloud today. We have over 40 sort of core services that we offer, and we practice what we preach. So one of the cool things about working for Amazon, and one of the most difficult and somewhat frustrating things, is the pace of our innovation. So, back in 2008, we introduced 24 substantial services and features. Last year, we introduced 516. So effectively, every day, we're introducing 1.5 new substantial features to our stack. So when you work with a cloud provider, you also can leverage their pace of innovation, whether it's us or our competitors, to actually help you improve your business as well, too. And because we're Amazon, we have a funny philosophy. So we don't waste money on marketing. We don't sponsor football clubs. We don't put in ads in the MTR. We focus on our customers, and we focus on volume, which is what we're good at. So we've actually decreased our pricing 48 times over the last 8 years. And remember, in our world, there's no contracts. So essentially, you use it for 1 millisecond or 1 hour. And if you don't like us anymore, you just discard it and you go somewhere else. So for us, it's really important that we focus on concepts like this because we need to retain our customers in the long term. So for us, we've never increased prices on anything. We've only decreased them, and in this case, 48 times over the last 8 years. It's a funny sort of philosophy we have. And just like Amazon, we're focused on scale. So if you believe Gartner, the capacity that we have within Amazon Web Services is 5 times the next 14 competitors combined. And that includes Microsoft and IBM and Google and CenturyLink and all those other parties that are in the cloud computing space. So that's it. Hopefully that wasn't too boring. And hopefully that was something that was valuable for you. But what I want to do was give you a quick, hopefully, overview as to what cloud computing is, what the core concepts are, and why I think it makes sense for you to look at cloud computing concepts, even if you're not, even if you haven't been looking at them today. Whether that's with Amazon, whether that's with one of our competitors, whether that's at the SaaS level or PaaS level, there's heaps of value in doing so, and there's definitely a massive trend towards this space. So thanks very much for your time, and I guess we can open up to any questions if anyone has any.
Are there any questions that you haven't already asked for Zane? Sound not? Sorry.
Zane, thanks for the insights. I guess I'm interested, obviously the uptake in the IT services. We're hearing a lot about new e-commerce players here in Asia, here in China. Is this going to be a big part of your business in the future, supporting this new generation of entrepreneurship here in Asia?
So Anson's question was around, what's happening around the e-commerce ecosystem in general. A lot of companies playing in this space where they're supporting young entrepreneurs or startups in this space. So a couple of things. One, certainly from a cloud computing perspective, there's massive change that's happening. It's transformational. Random sort of side note, historically Amazon has kind of, not hidden, but hasn't really called out the size of the contribution that Amazon Web Services makes to Amazon.com's business. But you'll actually see during our Q1 announcements for the first time, we're actually going to carve out the specific Amazon Web Services component. It might be interesting for you guys to take a look and see sort of how big or how small that is when it actually is released. So around support for startups and entrepreneurs, that's a really important part of what we do. That's probably the most fun part of what we do, because when we speak to whether it's e-commerce startups or other technology startups, we'd love to learn about what they're actually trying to achieve, and we try to help them solve those issues. So we have programs here in Hong Kong where we support Hong Kong Science Park, Cyberport, a bunch of accelerators like Nest and AA accelerators, Accenture FinTech accelerators. And we don't do it in a really public way, but we support these startups and these organizations by providing them, one, credits to be able to run experiments with, so it decreases the cost of the experimentation, but probably more importantly, we support them with technical mentorship and business mentorship. The business mentorship is less valuable because there's lots of business mentors in Hong Kong, but the technical mentorship is pretty interesting because we help these companies essentially make sure they operate with the smallest possible footprint, which allows them to conserve their capital over time. So startups, for example, their biggest issue is going to be runway for operating their business. So let's say they're successful in raising a small angel round. That might only give them, say, 24 months based on a specific run rate based on having certain infrastructure. If we can actually optimize their infrastructure to be operating at a very minimal cost, but to handle spikes when traffic actually occurs, and we allow them to be able to match expenses with revenues, then it creates a model that's highly scalable. So we're very much active in working with small businesses, startups, and anyone for that matter around this concept of constant cost optimization.
I'm not sure my exact question here, but I'm trying to understand how.
Can you use the mic, please?
Sure.
I understand your business is storage and how to analyze all the information, but how do you offer a global service when you're not an ISP provider? And how does it work with the pricing model if I have different bandwidth available to me in Hong Kong versus Singapore, or any example?
So we are not an ISP, but we work with you and the existing capacity that you have to be able to leverage computing over the connectivity that you have. And in some cases, we do provide something similar to network capabilities for delivery, through something called a content delivery network. So in a more traditional web application use case, if you have customers that are around the world, we're actually able to store a cache of the content that they most frequently access and deliver that to that actual end user customer with the lowest latency and at the lowest cost. And so we have what we call POPs in over 50 countries around the world today. And these allow the information to be closest to your actual end user customer. We also do offer some interconnectivity between our infrastructure to allow you to do things like data replication if that's required. So I'd be more interested to understand what your specific use case is to see in what areas you would leverage your existing infrastructure versus where you might leverage our infrastructure, especially on the networking side. But in many cases, especially for companies that want to have more of a traditional experience, like an IDC type connection, we will work with folks like Rex's company, PCW Global, who is a partner of AWS, to actually provide connectivity between, say, an on-premise server room or a co-location into our infrastructure and actually have private connectivity between those. So there's lots of different models and ways to be able to leverage the compute and storage that exists in the cloud, and there's different ways to actually have that connection. Some uses public internet, some use private circuits for it. But most people, if you want, you should think of your cloud provider, especially infrastructure as a service cloud provider, as no different than an IDC, but with a lot more flexibility around the ability to be able to burst or to be able to auto-scale.
Great. Any last questions before we cover things off?
How safe is it?
How safe is it? So, safety, of course, and security is the most important element for any cloud provider. So for us, we've been in operation since 2007, over 1 million customers around the world, 190 countries. I don't have a slide in this deck around certifications that we have because I haven't really talked about our products. Security is the most important thing for us. If there's a single security issue, that could compromise our entire business. So, all of our security documentation is available online, some under NDA, some are public. We publish certifications that allow you to be able to review and your auditors to review to ensure they're compliant. We work with the regulatory bodies within each market to get workloads approved, especially in regulated industries. We ensure and make sure that our component of the infrastructure is secure, but security is not just an onus on us. There's actually a second component, which is what's called a shared responsibility. So as a user of cloud services, you have to make sure you take at minimal basic precautions, and in some cases more advanced precautions. In the same way that you would protect your own data and protect your own infrastructure within your own facility, you want to do the same within the cloud computing environment as well. But the great thing is you can replicate it. So if you require what's called multi-factor authentication to access services, if you require key management services to keep shipping and rotating keys, if you require a hardware device called HSM to manage keys, those can all be supported. If you require encryption of data in trans or at rest, that can be done. If you need data obfuscation, data masking. So all the core concepts that you have around security and governance and risk that apply to your IT products that you do today can apply to Amazon and most other cloud providers as well. But for us, it's the single most important thing about our business. And the moment something like that happens, if it happens, which we hope never happens, it could be catastrophic to our business and to the industry. So anytime anyone in the industry suffers from something, it actually harms the industry as a whole. So it's something that all of us are really, really focused on ensuring we make sure is really well addressed. In many cases, you might actually find out that the security infrastructure precautions that we have internally might actually be more secure than what some companies do. So Hong Kong is a good example where you might have a server room that's in your office right now, and someone can just walk in and can yank out cables and take down your business. Our world, of course, is basically impossible to do that because of the structure that we have around security. So if that is a concern, we're happy to walk through with you your individual concerns that you have and figure out how and where either we can help you enhance security or areas where we meet your existing requirements.
So how do you manage with country specific?
Yep.
Certain countries, I don't want to take names,
Yep.
but how do you manage countries like that?
So we have to be compliant with local laws. Yeah.
Sorry?
We have to be compliant with local laws. This is number one thing. So in the world of data, you often have what are called data residency or data sovereignty rules. So in Asia, there's specific markets here where that's pretty clearly a requirement where the data must reside in those markets. So from a technical perspective, you would help the customer or the partner or someone would help you architect your applications so that they are consistent with whatever the local requirements are. So that's not a difficult thing to do. So the applicability of those security or regulatory requirements are no different than what you're already doing with existing systems. You just have to think about how are they architected in the world of cloud computing.
Zane, we hear a lot about China, mainland China, and the firewall of mainland China. How's that been for you, for Amazon Web Services? Are you flourishing or is it a challenge? I did actually meet some of your guys in Beijing.
So we have infrastructure in China as well, but we kind of have what you can say is AWS inside of China and AWS outside of China. So our approach is to ensure we're compliant with local laws. So there's different licensing laws around things like something called an ICP license, an IP registration there, that are very different than outside of China. And so we operate our business in a way that is consistent with what the Chinese government requires us to operate. And that infrastructure, in this case, is actually completely isolated from the rest of our infrastructure around the rest of the world. So we have to deal with that in the appropriate ways that are respectful of local laws and customs and requirements. And so the Chinese market is a really exciting one for us. We've made some really heavy investments in it, and we have heaps of customers in that infrastructure today. But business is different there. So how you onboard as a customer is actually very different than how you onboard, say, here in Hong Kong or in Singapore or elsewhere in Asia. So it's not perfectly homogenous, this whole concept today, but that's just how it is in some cases.
So I think we're just out of time now, but appreciate Zane coming in today. We have a little token of our appreciation. For those of you that still have some questions, please feel free to stick around for a few minutes. I'm sure Zane will be happy to entertain those questions. Equally, if you want to continue networking, please do that as well. We have a website, the AmCham website. You can go on there. You can look through the different committees, what activities are being planned. I encourage you to do that if you haven't found that website. Give you a little bit of idea of some of the other activities that are coming up. And again, thank you all for coming today, and hopefully it was time well worth spent. Thanks.
Very nice meeting you.